Sound the trumpets! Guys, this is it. This is our final video with RJC Teach Productions. We're going to do Earth history before I'm history. Get it? Okay, anyways, this chart on page 8 and 9, this is the history of the world according to mainly one thing. Fossils. This is the history of the world according to the fossil record. And guess what? This whole thing is like a layer cake. It's like a layer cake, and guess where we show up? We're at the top up here, humans. Okay, and as further back in time we go, the more primitive creatures get. According to the fossil record, there seems to be a progression of different life forms on the planet. Okay, so youngest rock, oldest rock. Youngest fossils, oldest fossils. And then this is just the record in which we see life on the planet. Why do we see life? Because almost all these guys are either bony or have some kind of hard parts. If they have hard parts, they fossil pretty well. If you don't have hard parts, if you're just a jellyfish, or if you're just this moss, or if you're just this algae, you don't fossilize very well. So yeah, we talked about earlier how that stromatolite thing, when we talked about sedimentary rocks, or some of the oldest rocks on the planet, you can't see that at all on this chart, but in your chart at home you can. On page 8 on your reference table it says stromatolites here, and it says, actually right down here it says stromatolites, 1,300 million, that's 1.3 billion years old. And that pretty much represents some of the oldest life forms on the planet. And the only reason we see evidence of those is because everything seems to be swirled and mushed together. Usually you have to have hard parts for fossils. That's why this part of the fossil record, which actually squeezes up into here, Phanerozoic meaning with life, Precambrian meaning without life, Proterozoic early life, Archean really old stuff. And so what we have is we have eras of time: Cenozoic, age of mammals; Mesozoic, age of pretty much the dinosaurs; Paleozoic, age of early crispy critters, all kinds of early life, early fishes, early amphibians, potato bug kind of guys, trilobites and all those. And then we have pretty much pre-life, which is some gooey things that we find in the ocean, but usually don't fossilize. Once again, no hard parts. You guys got to read all this stuff on your own. Okay, this is the Earth pretty much with life from 0 to 500 million years ago. From 500 million to 4.6 billion is pretty much the Earth without life. That doesn't mean without completely. That just means pretty much without life. Earth with life, Earth without life. That's why they blow up this big part. Now, how do we arrive at this? Well, I said that's a layer cake. So what are we talking about? We're talking about this. We're going to have to focus the camera right over here. And maybe I can put it over here so you can see it better. Film director, right over here is fine?
Yeah, it's fine.
Okay. And so what we have is we have layer 1 formed hundreds of millions of years ago, formed tens of millions of years ago, and forms today. Pretty simple, right? So, relative to this top rock, this bottom rock is older. Is that a hard concept? This is called relative dating. Normally just occurring in parts of West Virginia. But today, we're going to talk about it right here. Nothing truly against you, West Virginia, but you know. Anyways, so, rock on top, youngest, rock on bottom, oldest, we don't know exactly how much. So we just say relative. Relative to this rock on top, this rock at the bottom is older. How do we know? Well, it's going to contain older fossils. It's going to contain older sediments, older minerals. We're going to notice by different pieces of evidence that this holds true. This is actually a law. It is called the law of superposition. Super means above, like Superman. Position is where you are. One rock layer is superimposed on the other. It is the law of superposition, which states, under normal conditions, youngest rocks on top. Unless you had some serious plate tectonics going on. Because if you had some serious plate tectonics going on, you could have this. And it's like, oh, there's a dinosaur. I told you dinosaurs and humans live together. No, okay? It's where the rocks have completely overturned. Doesn't make any sense because in every other place on Earth, you see human fossils, dinosaur fossils way below, no contemporary existence whatsoever, things like that. That's called relative dating. Now, from relative dating, what we have to be able to do is correlate rocks. Now, what does it mean to correlate? What it means to correlate is to line up. Because what you can have is a situation like this, where you have like different rock layers in different areas, and you got to kind of piece them together. Well, how do we piece them together? Well, we can piece them together by thickness, by rock type. We can piece the history of rock formation, the history of the earth together by noticing similarities. So what we have is we have this conglomerate here, and we got a black shale below it. And we have a conglomerate here, and we have a black shale below it. And then we got a limestone below that, and then we got a limestone below that. And then we have a shale which contains trilobites below that, and we have a shale which contains trilobites below that. We have a conglomerate there, and then we have a shale there. Well, what's going on here? If I really look at this, I got to be able to correlate these outcrops of rock. Outcrops is a fancy word for rock sticking out of the ground or near the surface, that we can line them up. So what I'm kind of thinking is that this goes with this, and that this goes with this, and that if I piece it together, this is going to be the youngest rock in the diagram, and this thing down here is going to be the oldest rock in the diagram. I did that by the rock type, I did that by the rock sequence, and I did it most importantly by fossils. But you don't always have fossils to work with. Most people think, well, all fossils aren't all old rock. Actually, they're not. Fossils are special. And when we get them and can line up things, that's great. This is called interpretation of Earth history. Now, we'll talk about some really special fossils in a moment that we can use to really line things up and indicate what's going on. Before that, we have to look at what's called geologic puzzles. Now, geologic puzzles, we'll start off with one that's fairly simple, are kind of like this one right here. This is a geologic puzzle. Let me get it in view better. Okay, now what's going on? You got a couple things going on in this area. First of all, you have a rock layer of shale. Then you have a rock layer of sandstone. Then you have a rock layer of limestone. Then you have a crack in the rock, which we call a fault. And then you have a basaltic intrusion, which is oceanic magma that intruded its way, which works its way into the rock. It came up, and of course, what do we have all along here? We would have contact metamorphism. In fact, if you're really smart, what kind of rock would I get right here, which is the contact of magma on limestone? Page 7, Earth Science Reference Table, you would look it up and find out that the contact metamorphic rock there that limestone turns into is marble. You would see it's marble. Just like in the sandstone area at the quartzite. A lot of overlap of concepts going on here. Now, you got to figure out the history of what the heck happened here. Well, the shale is the oldest, then sandstone happened, then limestone. And then I am positive the next thing that happened is the rock cracked. Critelli, how do you know that the crack of the rock, the fault, is actually older than the intrusion? Do you see the intrusion snapped by the fault? No, nothing happened in the intrusion. The reason that nothing happened in the intrusion is the ground broke, and then the magma came through the whole thing. So if you're asked, what is the youngest thing in that whole area? What is the youngest rock in that whole area? It's the intrusion. Let me give you an example of where that's not true. If you had some rock situation like this, once again, they're going to, as I digress, they're going to ask you what kind of rock you get there with contact metamorphism. Of course, since it's sandstone, it's quartzite, page 7 or Science Reference Table. You're like, score, I know how to do this. Okay, but anyways, so now we have a situation. What's the oldest rock layer? Well, the ground faulted. It appears that this should be lined up with this. This should be lined up with this. And it's not because they're the same rock type only. It's also because they're the same thickness and the same sequence. Everything's got to line up. And this should be with this, and below there should be this, but we can't see it over there. So this is what I think happened. This is the oldest. Then this rock layer happened. 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 And then this rock layer happened because, look at this intrusion. I think after all the rock layers were laid down, the next thing that happened was the intrusion of magma. Now, how do I know the intrusion of magma is actually older than the fault? It's easy, guys. Did the intrusion get broke? Yes. Do not listen to those people. Do not listen to those people. They are interrupting my video again. Let there be no peace in this building.
That's what you need for today. Thank you.
All right, so anyways, here's the intrusion, there's the fault. The fault broke the intrusion. That shows, and the fault also broke the top rock. That shows the fault is the youngest thing in the area. There's something else. Did the intrusion contact metamorphic this rock layer? Did it contact metamorphose that rock? Yeah, it did. Since there's those little lines showing contact metamorphism, you can't get burned unless you come into the room where the heat is. This rock had to have already been there. It didn't sprinkle on top and form afterwards. It had to have been there to get changed by the magma that was touching it. Let me show you what I mean in this case, because a lot of people get really, really confused about that. I can show you with a diagram like I have a few. I'll show this one. This one's really cool. This one will show it. Okay, so this is a very complex diagram, but not so bad. B's definitely the oldest thing that happened in the area. A's next. Then probably H got deposited. Then you have a situation right here, which we'll talk about in a second. And then D got deposited. And then E was deposited. And then the ground got intruded. Critelli, why did you say that F got deposited? Simple, real simple. Do you see any contact metamorphism in the limestone layer F? No. There's a simple reason. It wasn't there. You can't get burned unless you're there. So F did not get contact metamorphosed because the C, and I know it's a C, page 7, Earth Science Reference Table, by evaporation and precipitation, put that limestone there. So all these rock layers formed, including E. I know that E was there because it got touched by the magma. Then the magma came through, fried everything. It was only touching the air because there was no rock at that time. Then, over time, this rock did form, and then the sandstone formed, and then, since the fault affects even the sandstone, the whole thing broke. The whole thing broke. You have to be able to piece together the geologic history of it. I'm not going to lie, I love this stuff. These are like detective puzzles. You guys get to work them out. I'm going to test you big time on them, and hopefully you get one on the exam because I think they're cool. Now you see this right here? You see how all these rock layers are bent, and then there's this thick line, and then these rocks are all flat after it? That's because that's a do-over. What do I mean by do-over? If you're reading a book, a really good book that you're really enjoying, and your little kid brother or sister tore a whole chapter out of it, the story would no longer go together very well. You'd have to actually figure out what's the gap, what was in the gap, what happened to those characters. This is a time period in history where, let me show you, I gotta lower this because I'm a little vertically deprived here, where history was actually, watch, history was actually eaten away. Because history was eaten away, there's a piece of history gone. Maybe it's two different ages of rock touching each other. Maybe it's Cenozoic era actually being touched by the Paleozoic era. The whole Mesozoic with dinosaur fossils is gone. When you have a piece of the history of the earth gone, the history no longer conforms. It is called an unconformity. I'm going to write that word down because it's huge and it's big. It's called an unconformity. And what does an unconformity mean? One word. It means one thing. What happened is erosion. Now let me show you more obvious unconformities. All right, here's one. Oh my gosh, super obvious. Look at all this action with these rocks. These are all bent up, they're all folded, evidence that the rock has moved. And then you have this. And you have this. And all the rocks are flat above it. It's like, really? Simple. What happened? Mother Nature did this. It ate the rock away. That history is no longer there. You could have several periods of time on page 8 and 9 of your reference table gone. And when the history is gone, it no longer conforms. to the way it should. An example would be this, right here. This shows you in terms of names that you actually have Cambrian shale covered on Carboniferous limestone. People, you have Ordovician, Silurian, Devonian rock gone. Periods of time on page 8 and 9 of your reference table are just gone. No longer there. That is called an unconformity. Let me just show you, see if I have one more here, just to show you what's going on. Let's see if I have a good one. Just looking, and I'm actually going to go with this. Even though I don't think this is a great one to show, it'll be okay for the purposes of what we're doing here. This one shows the unconformity as a buzzsaw straight line. That's not typical of most realistic diagrams, but obviously, is this a start over? Hello, big time. I have a question. Was the limestone, actually it's tilted on its side, there's dolostone, that's limestone. Was the limestone present when the intrusion came through? Yeah, because what happened to the limestone? It got contact metamorphosed. It shows it. Was the shale present? No. The magma came onto the ground, blobbed all over the surface. The shale is youngest. The A is younger than the shale, and this shale, which is